everybody. It's Megan Jones from ICEAA here again with your machine learning working group. Today we've got another webinar that Dan Harper from MITRE is going to take the helm for on us today. Everybody, we're going to be keeping the microphones silent until the end. If you have questions, please fill them out. Please write them out in the questions box. Towards the end of the presentation, we'll check back in with you to see if you still want to ask your question or if it has been asked yet, and we'll take it from there. So with that being said, Dan?
All right, thank you. I am sharing my screen, but I'm not sure which one you're seeing. Are you guys seeing the PowerPoint in full screen mode?
In presenter mode?
Secondary presenter mode.
Okay, all right. So let me just try to share. I'll try to just share the presentation. Sorry about that. Welcome, you guys. We're going to start off on camera here a little bit, and we'll probably go ahead and turn that off for the speakers. I mean, for myself when the speakers start. So let me, sorry, I haven't go to meeting a whole lot, but I'm trying to reshare just the presentation. You guys seeing that now?
Still presenter mode.
Still presenter mode. Okay. All right. Well, I'll try to just work on that a little bit. You know, I don't want to slow things down too much. I'll make it at least as big as we can. And I'm just going to kind of introduce, and I know we have limited time here, so I'll let Karen say anything if she wants to. But first, I'll introduce our speakers. I even went ahead and looked up a little bit. First, we're going to have Adam speak a little. If I can hide the GoToMeeting icon here. We were just talking about all the funny videos of kids walking in and dogs, and you know, just the technical aspects too of working remotely. Although I don't have any excuses because I already work remotely, but you can see I'm still learning. So Adam is a senior analyst at Technomics. He supported a variety of tasks for the service centers, NAVC, DHS, and OSD, developing advanced tools and databases and performing statistical modeling. His 5 years of experience includes supporting OSD CAPE solution. He holds a MS in statistics and BS degrees in math and science from Virginia Tech. Go Hokies. And I'll also go ahead and introduce our second speaker, Bryan Anderson. He's a consultant with Cobec, focusing on operations research and software development. Recently, he's helped several data systems and supporting the FAA's IP&A operations research group. Prior, he was an industrial engineer improving supply chain operations for a national grocery wholesaler. Mr. Anderson's academic background includes a BA in economics and mathematics from Augsburg College and an MS in industrial and systems engineering from the University of Minnesota, Twin Cities, where I believe ICEAA is going to be in a couple of years, hopefully. And Tom, I didn't have any background information on you, but when you speak, if you could go ahead and just introduce yourself, just give us a little bit of your background.
Okay.
Yeah, I'm going to go ahead and pass it over to Adam, who is presenting first. Unless, Karen, you had anything you wanted to interject first.
Nope, everything looks good. So
All
go
right.
ahead.
Okay, well, thanks, Brian. Thanks for the introduction. So just to overview here, quick topics presenters will be myself, Brian, and Tom. And the topics we want to cover today are on the topic of tools, machine learning tools. What are they? So I'm going to go over a bit in terms of what is a tool, because it's not exactly clear what a machine learning tool might actually be. There's many ways to think of it. And then I'm going to go over R and pass it on to Brian, who will talk about RapidMiner and Python for a bit. And then Tom is with JMP, so he can help go through some of the details with JMP. So next slide here. So there's a couple machine learning use cases, a few big ones that I just wanted to go through it first, because it does make a difference when we start to talk about a tool. Often you'll hear these things called production models, where a production model would be something that you train, throw into a production system, and some type of automation ties back into it. So think of the way that a machine learning model might be trained to predict what show you might want to watch next for Netflix, or to detect fraud for banking and credit cards, or when a system might go offline or online in a complex manufacturing environment. Often those are models that are built and deployed onto a system that get consumed and used by an end user in some automated fashion. That's not necessarily what many of us will be doing with machine learning applications for cost and our acquisition support. We're going to be more dealing with the desktop. So I'm going to call them analyst models. They're created on the desktop, is used on the desktop. They're for a smaller team. They can still be highly complex and use very large data sets, but really it's not about processing and streaming real-time data or information in the system. So both use cases actually have overlapping tools, but this presentation is really going to focus on the left there, the analyst model. So next slide. So what exactly is a tool? There's a couple ways you can think of it. I like to think of it as kind of a platform and then toolkit. So a platform is that central hub, so to speak, that serves as your workspace. Some of these have built-in and integrated machine learning, others do not. So really, is that your tool? Or there's a specific toolkit that are libraries or APIs that deliver machine learning power. But those you can't just like use. You need to interface them with them from somewhere, which is typically some type of central platform. So there's my short little cartoon at the bottom. You're going to work out of some hub and then interact with things. I think that's simple enough. So moving on to 5. So what is a central platform? So there's kind of 3 main types I'd consider here. Graphically based. So you have this menu-based tool. You can point and click, drag and drop interfaces. More comfortable to work with. It's that point and click type interface we're used to. Even Excel would kind of fall into something like that. They often have access to script editors for things more powerful, and they often interact with compiled code through some type of API. Next, there's things that are script-based. So these are code-based, but they're typically being user interacts with them at a high-level function. They typically interact with compiled code through an API as well. The last one, which is compiled code, is doing crazy things and programming to do machine learning. Essentially, the user here is a programmer. So if we give one click here, just so my arrows pop up. Typically, when you're using a graphically based program or a script-based program as your central platform, somebody else does the heavy lifting for the code for you. They coded and compiled these libraries, and you just need to interface with it. So I know this is kind of building to a point a bit here. So if we get to the next slide. What this all comes down to is I use this chart for a lot of different things, whether it's business intelligence or data science life cycle or whatever. But typically when you're dealing with technology, the easier it is to use, the less control you have. And the harder it is to use, the more control you have. And obviously there's exceptions, and the goal of any good software shop is going to be to make things as easy to use and give the user as much control as possible. But this is kind of a generic model here. And what you get is no code all the way on the right, and then custom development all the way on the left. So if you look at the spectrum here, these point and click softwares kind of fall under the ease of use end of the easy. So you typically have less control, and maybe they open up more control to you, but as you start to use that more control, it gets harder to use. And then things that sit in the middle, like these scripting languages, R and Python, they can kind of run through the gamut of here depending on your use case, but people tend to like them as they provide this balance in between. So that in mind, move to the next slide. I'd like to get to some more interesting stuff, hopefully. I'm going to go through each of those categories actually out of order, because the first I'd like to talk to is compile code. There are programs who do machine learning, so to speak, purely out of Java or C++. These people need speed. They're dealing with massive data. They're trying to deploy. They might have a programming background, and I don't really want to talk about them anymore because that's not where any of us want to be. But this is essential because they often publish and release APIs for this compiled code that we need in order to do things fairly speedily. So next slide. Low and no code is very popular. They tend to be a mix of proprietary and open source software. A few were actually very popular in the early stages of machine learning. You see them pop up in academia a lot. Things like Weka or Weka, I don't know however you want to pronounce it, RapidMiner. They both have open source and available versions. I know RapidMiner also has a commercial one. And then many of the traditional statistical companies have developed some pretty powerful, impressive offerings. So this is an exhaustive here, but there's SAS and Jump, JMP. Jump is kind of the graphical product for SAS. Tom, correct me if I'm misrepresenting it all. I'm sure you'll go into plenty of detail there. But Alteryx is another one. There's others. I mean, if you Google for these, there's just a slew of them. Some have been around longer than others. I'm not trying to call out any as better or worse here, just trying to give you a flavor of it. And then a lot, if not all, of the cloud providers have their own toolkits and APIs you can access. So Amazon, Microsoft, Google, they all have machine learning toolkits, platforms, and offerings that change so quickly that you probably need, a 2-week session overview from each provider just to be, up to speed on their offerings. But that's my lightning round of low-no code, and then scripting languages. So scripting languages are very powerful because you don't need to pay for them. They can be frustrating to get started with, to be honest, and they have some disadvantages. You have to write code, but I know they've been coming a lot of talk about them as late. So the two main ones we're talking this are going to be Python and R. So I will now go and cover a few quick things about R over the next few slides before passing along to Bryan, who will take up Python and RapidMiner, and then again to Tom at the end for overview of Jump. All right, so R. I think we've given some overviews of R in the past, but I guess I'll say a quick thing about it before I jump into it. It was a general purpose statistical language developed years ago. I think version 1.0 went up about 20 years ago, but it's become very popular. You can do a lot with it. Very good for moving around, manipulating data, and it's a statistical package at heart. So it wants to do data analytics, and really a lot of machine learning algorithms are they're either a rebranding or an evolution of a lot of classical statistical methods. So R can deal with that pretty well. But really using base R into base functions are going to kill you. You're just going to be doing so much by hand that there's a concept of frameworks. So I use this as an example. A standard workflow could look something like this, right? You're going to import your data, you're going to prep your data, and that's going to take ages because we all know that, but you're going to import your data, prep your data, train a model, test a model, and then rinse and repeat for other algorithms. This can be tedious beyond belief to do in R. The reason is there's no joke hundreds of different libraries for machine learning routines. If you want to run one type of algorithm, you're going to use one library. You might use 4 different libraries just to test different convergence mechanisms of that algorithm or different variety of it. You're going to constantly be switching in and out of different packages, and each package might require a different format, data in a different format. One might want you to input your data as a matrix, while one might as a more tidied up data table, and every time you try to run a different algorithm, you're going to have to clean and manipulate and move the data around. And with machine learning, that is what you do. You run multiple algorithms, you test, you train, you tune, you do this repeatedly. So you definitely need to solve that, and that's where frameworks come to mind. So frameworks, what they do is they standardize processes, so you spend less time worrying about how to configure things, more time actually doing the work. So if I'm not going to cover all of them. I'm going to cover about the 2 most popular ones. Probably not going to learn too much other than where they are, what they are, but hopefully it serves as a good launching point for somebody who wants to delve into it a bit more. Go to the next slide. Those of you working with R a bit are probably familiar with the concept of the tidyverse. So the tidyverse is a collection of packages maintained by pretty much the R giant right now, RStudio. They're a private company who does a lot of development and work within R. But really their goal is to build code that runs quicker, is easier to write and read, and just kind of like makes sense, their overall philosophy. So most new R users actually learn R in the tidyverse setting. It's just what's taught a lot at a lot of these data camps. So the Tidy Models framework is actually a collection of packages managed by them to facilitate modeling, including machine learning. If you go back a few years, there was a package called CARET, which stood for Classification and Regression Training, and it was being led by an author, Max Kuhn. That was pretty much the go-to framework for a lot of the R modeling early on. He has since been hired by our studio and is building out the Tidy Models framework, which has superseded it. So it's well maintained and resourced. They're pouring resources into it, and it's constantly growing. But it's still evolving. There's certain areas of it which are shifting so quickly that it might be frustrating if you're just trying to get something done. It's still maturing a bit, but overall, this is kind of where a big part of our community is shifting there. So I think to quote from them, Tidy Models is a meta package for modeling and statistical analyses that share the underlying design philosophy, grammar, and data structures of Tidyverse. So it's supposed to look familiar for those of you dealing with that. And there's their GitHub page. So if we go to the next slide, just to give an overview of what we're talking about here, I don't know how they come up with the name of some of these packages. Broom, that makes sense. You're sweeping, you're cleaning things up. When you run different algorithms, the output might look different from every package. Broom helps you tidy them up so you can run a bunch of different algorithms and look and compare them across different formats. Parsnip, I don't know why it's called Parsnip. I think they have a story behind it, but it helps you kind of tidy up an interface to create models. So you can specify an X and a Y and just pass that through different algorithms instead of always having to mess with it. Recipes pretty much helps you set up pre-processing steps, and that way you can change the data and just kind of rerun those series of steps and have it redo it. R sample, do stuff like sampling, resampling methods, so as you're trying to do like bootstrap and boosting, things like that. Workflows, I haven't dealt with much, but it does help you combine things into objects. Again, it's all about setting up steps that you can hit go on rather than having to constantly tweak all these parameters. Yardstick, tools for evaluating models, and then something I've used quite a bit actually, Tidy Text, I point out because it's useful for natural language processing, the quantitative text analysis. That's an overview. If you're interested in this framework, they have a lot of documentation. You can poke around their site. So that's one of the more popular ones. If you look at the next slide here, I would say these form the big two. This one's MLR. I think Machine Learning R is the name. It used to be MLR, and now it's MLR3. I don't know why, but it's an evolution of it, and it's kind of a rebuild. And you can see how the framework works in the same way, right? It's about creating these data pipelines, these tuners. You're separating out your different components of a machine learning system or workflow so that you can focus on one area and then tweak and manipulate other areas without having to redo your whole workflow. So it's a good thing to do from a data science perspective, even if you're working in Excel. But these are the two most popular frameworks, to my knowledge, Tidy Models and MLR. So I think if we go to the next slide, just kind of some other notes on this. The frameworks are powerful. It's probably what you will want to use if you're using R for something larger. That said, it's probably easiest just to get your feet wet using some of the standalone packages. Use the data, clean it up, and then try to fit some basic models if you're getting started out here. So if you go to the CRAN task view in machine learning, it gives you a lot of information there. Some things I've used, which are pretty simple, GlimNet for some standard regressions, Lasso, Ridge, and stuff. TensorFlow is an interface to Google's TensorFlow library. Keras is an interface to a few deep learning libraries. There's an R API around that. I think Python has one too. Random Forest I've seen used in a few ICEAA presentations in the past. Very simple. Naive Bayes, H2O, XGBoost, they all have their uses. But those are some I'll highlight that if you're trying to get started, just get some things to run. But regardless, data preparation and the feature engineering side are key before you can use any of these. So I think that wraps it up for me. I think the point was just to give hopefully some clarity in terms of what a tool is. It kind of thought of a little differently and hopefully point people in the direction of at least where to start Googling if you're trying to get started with R.
Thanks, Adam. If you guys give me a second, I'm gonna try to reshare. I know, unless, Brian, unless you're gonna share your presentation, let me try to share it real quick here.
Well, not yet. You can control it, that'd be good.
All right. All right, can you guys see RapidMiner introduction as the slide?
I can see it.
Yes.
Excellent. Over to you, Brian.
Cool. Well, thanks, Adam, for the introduction to tools and frameworks and R. Learned a couple new packages in there, so that was good. As I kind of go through this presentation, if anyone has any questions or comments, throw them on the chat, or if not, give me an email and I can respond if there's any. But I'm going to talk about RapidMiner and R. As Adam kind of said, he was talking about different, I guess, platforms. He kind of had a concept of platforms with tile code and scripting code and all that. RapidMiner probably fit into the but RapidMiner is a data science company from Boston, Massachusetts. Been around since 2006. They have several different products that they offer. The primary one that I use has been RapidMiner Studio. As I said previously, there's an open source or community version, and there's paid versions as well. And those can range anywhere from $500 a year to thousands of dollars a year, and even higher. Can others see the presentation?
Green lines.
Yeah. Okay. Good.
All right. Sorry, I'll try to fix that.
No worries. Just making sure it wasn't on my end, you know. Or hopefully no one's on it.
Yeah, I tried to play with the display settings, and I think that was a mistake.
Hey guys, since we kind of have a second, can we take a couple questions?
Yeah.
Okay, cool. The first one we got was from John Balt. John, I'm going to unmute you so you can ask your question. Oh, okay. I will ask John's questions for him in connection to. Will you be talking about ANN as an estimating tool and, i.e. a force fit versus predictive model type issues?
So I think that's a specific method, and today we're kind of just going to stick to some of the tools overall. Unless Brian.
So yeah, I won't be talking about it in this presentation, but yeah, if you definitely want to talk about that in the future, I'll have to write it down.
Are you all seeing anything yet?
Yep, I see it again.
RapidMiner example.
Good.
Can we take one more question?
Absolutely.
All right. James Black, get ready. You're about to be live here. All right. Whenever you're ready, go ahead, James.
Hello. Can you guys hear me?
Yep.
Hi, I'm Jay. Worked for the Navy cost community for a long time. Currently work for Health and Human Services. I just had like a use case question. But first off, thanks for giving us a brief overview. I remember when I was a cost estimator, I never worked with like a gigantic data set. Like I wasn't looking at credit card transactions or bank records. I was looking at SRDR reports, software actuals. I was looking at 1921 reports for, production lots of, how much did it cost to build, lots of missiles as an example. I was just curious, like, could you describe a use case where you've used some of these tools, like, in the field, perhaps for those types of data sets?
Yeah. Adam, do you want to go first, or should I? Or anybody else?
I'm happy. I think that's a great point. A lot of these things don't have to be big data methods. You know, that's where the line between machine learning and kind of statistics, some purists are going to argue the semantics of it. But oftentimes you need powerful methods to take advantage of small data. This is my own views here, so cost analysts, we love analogies, right? So I think there's a tendency to subset data down to what looks the most like what we're trying to do, when you can borrow information from other related data and make use of some more advanced models that can take categorical variable descriptions, more categories and data points, and pull data out of it. An example of a use case that comes to mind for some machine learning would be imputation methods. So filling in missing data points and being able to use and gain more predictive power from a data set instead of dropping vehicles that you don't have a horsepower metric for to be able to impute that data. So things like that. I don't know if that answered it a bit, but you're right. A lot of these get talked to in a huge data context, but I think you can definitely do things more powerful and gain better predictive results even with these smaller data sets.
Do you have a recommendation? Like, is there a one of these tools to start with, just to play with like a small data set, just to try to, because I'm just trying to get smart,
Yeah. Honestly, I would grab whichever one's accessible within your IT systems to start. I mean, it sounds like a cop-out answer, but that's almost the biggest barrier in our community. So anything you learn on one is going to scale and relate to the others. It just is. They use a lot of the same language, a lot of the same ideas. So whichever one you can get in your IT structure, and then run through like the test or the hello world things that come with them. There's a lot of getting started things. Run through those examples and get a flavor for it.
James, this is Karen Maurikas. I was going to add, listen to what Bryan and Tom say, because they're going to talk about like different types of tools, and maybe at the end of the presentation you'll have a better idea of, hey, do you want to go with scripting tools? Do you want to go with a commercial tool that's out there? But then, yeah, definitely do what Adam is saying, is just start trying them out.
Okay, thank you.
Yeah, and just 2 points too also on that is, as Adam was kind of saying, using sophisticated tools and these ideas, they do provide new insight on data, which is always a good thing, but that's not to say not to ignore the old established ways. Those are still very useful for us. And I also kind of hit on the issue of collecting data and data quality. That is, kind of a new challenge that we're kind of facing as we kind of go forward. So, and one last thing on the data set, the Hello Worlds and tutorials, blogs, Medium, they all have kind of good introduction to a lot of these tools. And then if you really want like hardcore data to play with, and maybe not be such in a cost perspective, but Kaggle and data.gov have some pretty good stuff. So, yeah. Cool. Well, anything else? Should I start here?
We got one more question, and it's short, and I'm comfortable reading it. How do you define data?
That's a good question.
Right? That's pretty almost esoteric if you think about it.
What is life? I would just say anything that could potentially provide you information. It could be, verbal data, I guess, or it could be concrete in a, written down on a piece of paper, or it could be in a, Excel or like electronic style format. There's different styles of data, right? You got categorical and numerical and discrete, continuous. Does that answer the question?
I'm going to unmute if I can.
Yeah, Bryan, I think the wide categories of data tend to be structured and unstructured data. The beauty of machine learning is that it's uniquely fitted to to handle unstructured data as well as structured. So when we talk about regression, summary tables, mean, simple summary statistics, we're talking about this highly structured tabular data. And for machine learning, you can start to do things with unstructured things like audio signals, written text, pictures, images, anything that can help you gain more information. I like that first definition. Funny enough, step one of dealing with unstructured is to make it structured, but that's how I view it. But I think we might want to move into Bryan's presentation now.
Oh, just one, I promised to follow up to, this is Raj Kumar Raman.
Hi, this is Raj. I just have a question on data itself, because I think I look at data as information, and information can be in multiple forms. It can be qualitative, it can be quantitative, it can be visual, it can be any form of information is data. And in our world of cost analysis, the earlier gentleman mentioned, we are living in a land of limited data. So, and the kind of data we are used to is quantitative. But what is really happening in the world of cost analysis is there's a significant amount of what we call as graybeards and subject matter experts who understand, because in years and years of experience in the cost analysis field, and therefore their wealth of experience comes back into the analytical framework to make decisions at the highest level. What I'm looking for is a way, and I'm throwing this out to the entire team, is suggestions on how do you translate that years of experience into qualitative/quantitative data-based information, lending it to correlation, causation type of analysis.
Yeah.
Bayesian modeling. I say jokingly.
Yeah, that is a good question, and that is something hopefully we can solve. But yeah, I don't have an answer either for a good one.
Because the fundamental problem with all these machine learning and text analytics type tools is that we are very, very used to using these tools in the commercial world, where there's plenty of information to peruse through and scan through. What we have in the cost analysis world is, in the defense cost analysis world especially, I'm not talking about commercial marketing and cost and economics and that kind of stuff. In the defense world, the data is very limited. So in order for us to use these kinds of tools successfully, we need to connect the dots of qualitative and quantitative information, which is where the power of machine learning will come in. And I'm trying to get some clues or suggestions on how to go about that approach.
Yeah. And correct me if I'm wrong, but is this something along the lines of having implicit knowledge and making it explicit?
For example, the other gentleman talked about analogies. One of the favorite techniques cost analysts use is analogies, because every system that is built in the Defense Department is unique by nature. So in order to find analogies, we come up with complexity factors and all kinds of ability to normalize information across multiple platforms to make the case whether a certain program is going to be successful or not. All along the way, when that kind of presentation is made to the senior decision makers, inherent in that presentation is that wealth of experience that analysts bring to the table. I saw this program go behind schedule, ahead of schedule, on cost, above cost, whatever. And all that information gets translated into a presentation mode. And there is obviously, technically speaking, we can go back through 20 years of all kinds of presentation and scan the documents through machine learning and come up with keywords or key qualitative constructs to make or break the case of a certain analytical tool. And I don't know of any other way of doing it, but I'm open to ideas on what you might suggest.
Yeah, definitely. I don't have any good ideas right now, but if you want to pass the line or email us, we could definitely talk about this and get more of the details if you'd like.
This is Christian Smart. In my experience, Bayesian methods are ideal for what you're talking about. You hit the nail on the head that we have very limited data sets, especially for some very specialized products in defense. But using experience, using more generic data, those kinds of things, along with a limited amount of quantitative hard data that's specific to your problem, that's an ideal application of Bayesian methods. So there's a pretty rich literature on that and how to do that.
Your name, sir?
Christian Smart, S-M-A-R-T.
Are you in the DoD?
Yeah, I with Galarath. I support Department of Defense and NASA.
Okay. I'd love to talk to you offline.
Sure, be glad to.
All right, thank you, sir.
Yeah, Christian, this is Adam. I agree. I think we've talked about this in the past. Now you know you've done some ICEAA papers on it. Bayesian methods are a huge way to go for stuff like that. The problem is they're not easy. But anyways, I'll get off the mic now.
Cool. All right, yeah, good discussion. All right,
you can do a little bit of it in R. You can do it in R. There actually are some tools that are freely available that are specifically designed for using Bayesian methods, such as WinBugs, WinBugs. So you can do them a lot simpler in tools like that, but then it's a separate tool that you have to learn about and learn how to use.
cool. All right, yeah, check it out. All right, so RapidMiner, it is, as Adam said, it graphical-based platform. 2006, yeah, it's one slide. That's good. Here's just a little example of it. Each of these boxes represents a component or a process. There's about like 1,500 of them or something like that in there. And all of these things, they do stuff, data operations, transformations, executes algorithms, does all this stuff, and you can aggregate your stuff into other things called the components. But basically, you can kind of have a work items and create a visual workflow. And it's kind of like IT right there. 1 second. 1,500 operators. You can also have supporting scripting languages to create your own operators in languages such as R, Python, Ruby, whatever language. And there's also like data prep features as well. So if you want to, like, we're talking about data, you want to transform it, this tool also kind of lets you do that. Earlier, it was kind of asked, like, where is this stuff kind of applicable? One area that we have kind of applied in software estimating. We took your issue tracking system and were able to kind of help predict the durations of certain work items, and that would kind of help support the schedule and the cost. So we use this tool called RapidMiner to help us do that. It was extremely helpful to use in this to create the model. It took some clicks and running. If we had done it manually, it took us months. If we did with this tool, that's a plugin for that. Go on the next slide. Yeah, here we go. Review. So many concepts to know and understand. The learning curve is not as easy to excel. It's not as intuitive in some areas, but generally it's quite easy to make a model here than other languages. They have great interactive tutorials, as we kind of talked about earlier. They have really good Titanic tutorial, as everyone's probably used to learning various machine learning stuff, concepts. Where this really shines is the auto model feature. I really like that. You can kind of click and do some quick ideas right out of the box. So here, the model took an hour, but it took us a long time. So, next slide. I'm going to dive into Python a little bit. This is more of your scripting language area. Python was initially created in the early 90s by Guido van Rossum, which, as we all know, has evolved into a popular language. What's kind of cool about that I didn't know beforehand was, Guido is Dutch, and he kind of started creating over there, but he actually brought it over to Western Virginia and started or worked on and continued it at this company called Corporation for National Research Initiatives. So that was kind of cool. It was kind of more close to easy. Designed for readability. If you want to read what that means, you can Python at 20. Python has these things called PEPs, which Python enhances Python. It's kind of like the style guide and kind of the ideas and guiding principles of the language. It's one of the characteristics, software estimator, it's fourth generation language. It's supported on many operating systems, object-oriented, and one of the great things about it is the large online community information out there to learn about it. Some other weird things, as you kind of get into the details, it's, next slide, I don't want to talk about that right now. Oh, next slide. Cool. So, like ours, there's a lot of packages in there. These are just, I guess, that I think are useful for a lot of things I do. Far left is name, level is kind of where you are on, I guess, the learning page of Python, kind of next level is the area of useful, and just kind of general comments about it. In my mind, by far the most useful package for any sort of data analysis is it structures your data in a 2D format. You can be able to run quick exploratory analysis on it and get some quick feedback on what you're dealing with. Probably the most machine learning focused is Scikit Learn package that has unsupervised and supervised models and algorithms in that one. So for this group, that's probably the next package to kind of take on. But as we're just kind of talking about, this whole machine learning piece is in one stage of the whole data analysis process. Reporting with MATLAB and Seaborn and getting data requests, encyclopedia. So I won't go through all the details of these packages, but here's just a recommendation on packages to start with that are kind of machine learning. Next slide. So these are kind of the more popular machine learning packages slash frameworks slash ecosystems is what I've been kind of noticing on the web. You got your Keras, your TensorFlow, your XGBoost, CNTK. Those are kind of like ecosystems that you kind of tap in and use like a Python API. They call these other tools out there. But it's always nice to kind of get a good view of what else is out there and kind of get a feel for what people are working on. So in there, we got your commits and how many people have contributed. TensorFlow by far is the most active. I don't have a ton of experience. I just kind of played around with them before, but not in, I guess, a professional business project yet. So I don't know the ins or outs yet. But know them too. Next slide. Cool. We can breathe through these next slides pretty quick. But next slide. As Adam, we're like Adam's like at a six-step process, I think. Load data. So the previous slide is just processes. Check it out. Here's Python IDEs. It's very helpful to have IDEs to have good analysis. There's a lot of good features for wiretapping, such as autocomplete and linking, and just syntax correction, all that good stuff. I use PyCharm, which is a great tool. There's other ones out there. You can refer to think Spider or from Honda ecosystem. Notepad++ is a good one if you just want to dive into it right away. There's some other ones out there. And if you really want to go deep, go Emacs. That's the one I originally learned on. But it's kind of the hobby tool. Next slide is just a simple mind map of just packages and just how I categorize them. So if you start digging into it, you're going to see these packages are related, but they're different. For example, SciPy, that's going to be probably the most, any sort of data analysis package. It's probably going to come from there as you get used to if you're using Python. And then you get machine learning packages next, and then I call it structure, but that's how you do text. And then kind of reporting packages, MATLAB, Seaborn, Plotly, there's popular in JavaScript and R, I think. And then you kind of got your I/O with databases and protocols, and then and those are just third-party packages. Python has a lot of really great data packages built into the language itself, so don't forget to check out what they have to offer. And next slide is my last slide. As you kind of investigate various packages, here's just one example of how I set something up to wrap my brain around what's out there. Yeah, I don't know if we get shared community, but it's something just so we can start communicating and talking about some stuff. So just want to put a little bit out there to see if that can start a conversation. So with that, is there any questions?
We got a couple of questions on the chat box. Let me slide back up a little bit. Jeffrey Harris had a question. I'm going to unmute him. It doesn't look like I can, so I'm going to have to ask his question for him. It looks like he's making a suggestion, data.gov and baseball reference, there's a lot of free data there. And then we got a question from John Falk. So let's see. Okay, he also can't be unmuted. SME skill sets should be used to better make use of the data and the development as such, not an excuse to attempt to model the data itself. Actually, the rest of them that I got, you guys have covered. So those of you who are on the line and have some new questions, send them along.
Cool. Yeah, well, thanks for listening, and hope everyone's doing good with all what's going on.
Hey, this is Dan. Quick question or comment, I guess, that you guys had a lot of links to GitHub, and for those of us that I guess that's a place where people can share code, right? So, you know, maybe that would be a place in the future to share cost data. You all could always subscribe to CostFacts to share cost data, but I know a gentleman earlier was talking about the availability of resources. So I think the whole idea behind ICEAA, CostFacts, and these meetings is to share tips, share resources, you know, upload maybe useful tools and sites where you find data. So, you know, feel free to reach out to this network.
Yeah, definitely set something up.
We have
so why don't we
today.
hold I was going to say, this is Karen. Why don't we hold any more questions so that we can move into Tom's presentation since we're running out of time? Want to give him some time to talk about JMP.
It's Megan, just a quick thing, because a bunch of questions have been coming in on this. We will be posting the slides as well as the recording here on the machine learning group page on the ICEAA website.
Tom here. I guess I'm ready to go. If do I get to share my content somehow? And is it a hard stop at the hour?
The software won't turn you off,
Okay.
so I'd say no.
Okay. Is there something I should be doing to be sharing my desktop, or I'm still seeing RapidMiner?
Sorry, let me make you the presenter.
Thank you.
Okay, so you'll get the option to share your screen now.
Okay, and so that option is, oh, there it is, show my screen. I clicked show my screen. What do people see anything?
Yep, I see it.
Yeah, we're seeing your Let's Start GoToWebinar screen.
Okay, if I want to put that on a different screen, is there something I do?
I believe I think you can either right click on it, or when you click the button, click and hold it. I think it'll give you some options of other screens to show.
Okay, there we go. Trying to move some things around here. What are you seeing now?
Your Windows Explorer.
About this, do you see any slides yet?
We do. If you want to put them in presentation mode, I think we'll be good. Slideshow.
Yeah. Let's try that. Okay, so I have way more slides, so I just plan to pick a few out of this, and then I was going to actually show some things with JMP. So if I go into this mode, are people seeing the outline right now?
Yep.
So those would be the highlights that I think I would like to hit out of this. And so there's sort of two things I'm hoping to do. Well, first of all, I'm Tom Donnelly. I'm the engineer that supports the defense and aerospace part of the JMP customers. And I'm really a physicist by training, did design experiments for a long time, and really have been doing sort of data visualization and data analytics with JMP for about 12 years now. And so I'm going to go through some of these items here and then just actually show you JMP in action. So I've got I refer people to slides all the time. There's some terrific ones by Allison Wilson. She's the principal investigator at NC State's Laboratory for Analytical Sciences, so please check those out. I have all sorts of recordings at jump.com/fedgov on different types of building better models and machine learning methods. You can also see some by Professor Dick DeVoe, and the reason I point him out is that he frequently will tell people I use two tools. I use R and I use JMP. And I use JMP to do the stuff quickly and R to do the stuff that JMP can't do. And so I refer people to this link to where you can download a white paper on how JMP can interact with open source tools like R and Python. So the white paper is the link at the bottom. The link at the top of the screen would take you to this web page. And then the link on the right is if you ever want to get a free, fully functional 30-day version of JMP to try for yourself, you can follow that link. And this is sort of the typical JMP analytic workflow. We can pull data in from just about anything. Earlier it was mentioned that prep is going to take ages, tedious beyond belief in R. That is one of the areas that a commercial off-the-shelf tool like JMP can really help you do that quickly. And then ultimately when you're finished, you want to share those results, and we can publish our models in Python, C, JavaScript, SQL, all sorts of things. We can remotely run R, remotely run Python, remotely run MATLAB, remotely run SAS. And so in that sense, JMP is a very good place to interact with your data, to explore it visually, as well as do that data prep. And so the link at the bottom, I'm highlighting right now, we're running JMP on the air Monday, Wednesday, Friday. And the best 20 minutes you'll find is this link where the data doctor sort of shows how you can very, very quickly clean up data. And if you find it useful, he'll be on the air tomorrow doing the same thing again. And so those links will be active. You'll find JMP is referenced in well-known books in the field of data mining and for business analytics. And so there's also books specifically written about using JMP. And as I say, I work in the defense space, and so I frequently show this slide where I once heard Admiral Winnefeld talk about the fact that he had data, but what he really needed to do was move to that level of understanding quicker, and that so that he could take action. And I think that's one of the areas that commercial tools can help a lot, is getting you from, how do I get that data even put together? And then how can I, now that I've got that together, how can I get those models published quickly? So I'm going to stop those slides there and scoot ahead. Maybe just to this slide to preface the area of honest assessment methods, where we make it very easy for you to break your data into training, validation, and test subsets. I think most of the people on the air that are doing machine learning probably already do this. And so the whole idea is, how do you make all these machine learning methods, how do you make the process robust so that you don't overfit? And so we're really basing this off of seminal work in this field by Hasty, Tibshirani, Friedman. But the whole idea is monitor the test or the validation group to find out when you're overfitting and stop the modeling there. So let me just show you how we do that. Actually, just to finish this in sequence, we'll get back to that. This is an example, though, of 3 models in JMP, and it's meant to be interactive. So you can, I'm just going to do the video of it, but I could show this to you live. But you can reach into a model and interact. So this could be any machine learning model that you make. And you can say, well, what happens if I change this variable? And on top of that, you can even turn on things like desirability. And so desirability is you set goals for all of these responses. In this case, we're looking at 2 performance metrics as well as cost. And the question is, where in this 4-dimensional factor space can I find the conditions that give me the lowest cost and the highest performance? And of course, that result is going to be dependent upon, well, how important is cost to you and how important is performance to you? And so down below, I've actually saved several different settings when here's the answer if they're equally important, here's the answer if cost is 6 times as important. And so you can see that as you move around. Well, I've actually put this same thing, one of the ways that JMP can share results is it can publish HTML5. And so if you take your phone, you don't have to do it right this minute, but if you look at the QR code with it, you'll find that you can have an interactive HTML5 version of any of the models you build with JMP. And so at your leisure after this, go and put your phone up to that to interact with it. Okay. Again, I want to not do the whole slide deck. I wanted to cut to that idea of training, validation, and test. In JMP, we make that easy for you to do that, but we also make it easy to do things like stratify so that you make sure each of these groups has the right representation of the behavior you're modeling. So if it's, you're looking at malignant and benign tumors, you want the same proportion of those in each of the sets of data. The other thing we allow you to do is to also group your data, because sometimes you'll have replications and you want all of the replications to always be in one group so you don't sort of make the models look more favorable than they really are. Okay, scoot through a little bit and then I'm going to get into JMP. So one of the things that we try to promote to people as well is robust strategies. And one of the things you'll find when you start using decision trees, they're extremely fast. You can look at lots and lots of variables with them very quickly. And in the Bootstrap Forest, that's our name for the trademark random forest tool that I'm sure you've all heard of, is very effective at not missing an important variable. Once you've got those important variables, people will frequently want to get their best predicting model, and very often that will be a neural network, not always. But when you make those models are often can be very much a black box to people. And so what we encourage people to do is to back up a little bit now that they've explored the model with decision trees and neural networks. And it may turn out that a penalized regression method like the lasso will actually get you near machine learning accuracy with the model, but you'll also get coefficients that you can interpret as well as get confidence intervals on those predictions. So here is an example of doing a bootstrap forest where there were 44 factors. And notice this trick of putting in 3 dummy factors that are really just random noise. And by adding the random noise in there, when you get this result, sort of the Pareto chart on the importance of factors, you can sort of see where you know pure noise is. And so you can pretty quickly dismiss the bottom half of this just on the dummy factors. But even without that, you can still see that the ranking of those factors. And the idea is to not miss anybody. We also do unsupervised learning. We also do this data cleanup that I've mentioned. And I think at this point, maybe I'll show a few things. And let me just do a time check. Okay, and so here's an example of a data set. And we're going to do what's called explore patterns. And what we're able to do is we can turn on all of these features that we just want to take the data and ask questions about it. And these output tables where you see the column that says rarity, okay, think of that number as the number of coin flips you would have to get in a row for this sequence of data to have occurred in this data table. And so it's going to be a way to look at when you get data, what is the integrity of that data? Okay, we're not trying to say that this is going to spot fraud in every single case, but you're going to sometimes wonder how is it that somebody copy and pasted these data over and over again in this table? This tool is going to allow you to see that kind of behavior in a data set, so you can sort of judge the integrity of it. Okay, some other things that I wanted to show you were the ability to drill down in data. So this is looking at 200,000 rows of data for winter sports injuries. But notice, if I hover on a bar here, I actually get a new graph. So these were the parts of the body that were injured in those basketball. And then I could hover on one of the blocks in my tree map and look at the data by year. And then I could pick, say, well, this looks like what happened in 2009, and you could figure out what month things were happening. So this ability to visually drill down through data, I could see this in a cost analysis world as you have a work breakdown structure, and you could be visually drilling down through those those sets of data. So I have a couple of cost analysis I wanted to show. Here's one where I'm going to start it over. I've got cost data for electricity in California by months of the year for many years. And across the top of this graph, you can see all these graph elements. And so I could try to fit a line to that, look at density, connect the dots, bar graphs, etc. But I'm going to go back to this fit line, because what I wanted to show you is we actually give you the option of, rather than a polynomial, doing time series right on the fly. And so we know the period is 12 months here, and I want a forecast for 12 months. And so you can see that, except for the fact that I dragged the graph right at the last second there, back to a decent size, you're able to get that forecast. I see what happened is I put 1,000 forecast periods. I only meant to do 12. Okay, there we go. So very quickly, drag and drop, you're able to look at your data in this fashion. When it comes to machine learning, you know, we have almost all of the tools that you'll see out there. You can see lots of neural networks, decision trees, k-nearest neighbor, support vector machines. And then through add-ins, we even have tools like XGBoost here. Okay, and so I have another add-in here. This is probably an 8-year-old add-in for multidimensional scaling that somebody built. I need to get the right data set for it. Let me try that. So with this data set here, if I wanted to do multidimensional scaling, you'll notice that if I have SAS and R on my computer, I can choose one or the other. So I'll say, well, why don't we do the analysis in R? And drag this over. And when I click run here, you don't see it, but R actually went and launched, did the multidimensional scaling, and now I'm back in JMP displaying the results. So you can leverage people on your teams that can build tools in R that do things that JMP can't do, and take advantage of that. And I think maybe the last thing I'll show here is if I do a sort of a machine learning model, and so here I've done a neural network, notice again using my training, validation, and test so I don't overfit. When I get that model, I can of course publish it to my data table, but this published prediction formula actually puts it into a formula depot. And let me go get that depot, which is right here. And so you can see where that neural network's been published. Well, I have all these models published. If I need to turn that big, this was a boosted neural network, so 50 consecutive neural networks. I want to turn that into Python code. I can just choose to click on this, and now I can give this to somebody who wants to put that Python code into production. So let me just go back to the slides to wrap up. I think I was just about done here. Also wanted to point out, somebody mentioned earlier unstructured data. We also do text analytics. We also do functional data analysis. This is where your response isn't just a single point, it's a highly correlated stream of data. So think sensors. We can now model the shape of the curve so that the shape of the curve, when we do functional principal components analysis, we're now actually able to make predictions on that. So I know that was a blitz, but I hope you took away from this that we're often after not just the best prediction, but the most understanding. We want to prevent overfitting, so that's why we make it easy for people to use training, validation, and test subsets. And I also pointed out a robust strategy to make sure you don't miss variables, maybe get the best predictor, and then also back up to get the most understanding. So I'll leave my contact information up there for a minute. If you have any questions on this, or you want me to send you a copy of these slides, I'm going to send them to ICEAA, so you'll be able to download them. But if you want them directly, I'd be happy to provide them. So with that, thank you for the time and the invitation, Karen, to present to this ICEAA group.
Yes, well, thank you, Tom. I wanted to comment on that one slide, I think it was slide 45 or 46, where you had written in red letters something about the amount of time it takes to clean your data or prepare your data. Yeah, 60 to 95% of the time is spent preparing the data. And I think we probably all know that because we've been doing, whether we do machine learning or other types of data analysis, we know that it takes a long time, but a lot of people don't. And especially with the terms like AI and machine learning, some people think, oh, you can do this like, really quickly. And it's like, well, it's going to take a long time to clean up the data, and they don't necessarily understand that. So I've never seen it as high as 95%. So that's interesting to me.
Well, if you see the asterisk at the bottom, this is where that quote came from. So, no.
Okay.
But the point is, you'll often hear people talk about the data prep being the longest pole in the tent and the hardest thing to do. And the ability to rapidly recode data, find outliers, impute missing values, sort of do a data integrity check, those really are things that we feel we can do very quickly. And we often get people who will tell us, what they're now doing in minutes. They were spending hours and even days in other tools. So thank you for pointing out that slide.
All right, so I just wanted to thank everyone for joining, and I hope that you got an overview of different types of tools and methods that can be used for doing, data preparation and analytics, in particular, machine learning type of analytics. Next meeting, so last meeting, we gave an overview of machine learning in general. Christian Smart presented that. This meeting, we looked at some of the tools and methods, or methods of the tools, more likely. Next month, we're hoping to look at some applications. We do have one person lined up who we think is going to present. But again, this is an open call for all of you. If you have topics that you want to present or just discuss, let us know. You can contact us through ICEAA or any of the emails that you may have gotten from any of the folks on the steering committee. This is really about your community. It's not about what the steering committee wants. We want to help make this community successful to meet the needs of the community. With that being said, does anyone else have anything they want to add from the steering committee, or if you're on mute, you could send it in the chat window.
We haven't gotten any questions from the chat window in a while, so I'd say you're up for closing remarks.
Okay, I think Dan mentioned earlier, and Megan also, that one of the ways we communicate is through CostFacts. So if you are not a member of the CostFacts Machine Learning Working Group for cost analysis, make sure you sign up for that. When we post these slides, we will make sure there's a link in there for you to get to that. And these slides will be posted at the www.iceaonline.com. It's at the ICEAA website. And again,
I'm on CostFacts as well. So, yep. Sorry, Karen.
Okay, no, I was going to thank Adam and Brian and Tom for presenting, and also Dan for hosting it today, and for Megan for doing all the logistics.
Well, thank you guys for every month putting out some great content for everyone's benefit. So on behalf of ICEAA, thank you all very much. I hope everyone has a good day, stays healthy, stays sane, and we'll talk to you guys next month.
Thank you very much.